Hello folks, welcome to Rapido.io's tutorial. Today we will learn about running a variation of ROS Turtlesim on Rapido.io. In this video, we will start by building a Docker image from a public Git repository, pushing that Docker image to Docker.io, and using it in an IO package. We will also learn about how to expose ROS topics, services, actions, and network endpoints. We will also learn the concepts of routed networks and dependent deployments. At the end of the video, you will be able to control a Turtlebot in simulation through a web browser. Before beginning this tutorial, make sure you have access to a computer with an internet connection and you are familiar with Git, Docker, and ROS. And in ROS, the concepts of topics, nodes, and services. So let's begin. First, let's open up Rapido.io on our browser by going to console.rapido.io. What we're going to do now is going to create a new project. We go to the side navigation bar, click on projects, and click create new project. Enter the relevant name for your project. So Turtlebot Sim demo, and click continue. So now after we're done with our project, we're going to create a build. Go to the left menu bar, click builds, and add a new build. For the name of our build, we're going to put IO tutorials. And for build recipe, keep it as catkin. And for the repository URL, just fill in the repository URL of the project you're working on. So for us, it's github/rapido/IO tutorials. You can find the same link in this description. Afterwards, click on Next. Over here, you'll see some additional details of the build, such as the architecture and a ROS version. Let's just leave it as default, and since there's no Docker, leave it as default. And now we can see that the status that it's building. Okay, so now you can see that it's building in progress. Meanwhile, we're going to create a routed network. A routed network is basically like a network where certain nodes or containers can communicate each other through the cloud bridge. So over here, you click routed networks, leave ROS distros kinetic, and then click continue. Okay, so now if you go to the network page, you can see that it's deploying in progress. The network usually takes a minute to deploy. Now you can go back and check on your build, and it's still building. The next thing we're going to do is we're going to create an IO package. So in IO packages, click on Add New Package and enter a name for the package. Just going to call it Turtle. And for singleton versus bindable, make sure that it's bindable. And you can optionally enter a description. Click on Next. Over here, we're going to enter some component metadata. So you can enter the component as turtle, whatever you want. And the ROS version must be kinetic. And here we're going to write an executable name for the executable. And for executable type, let's pick the executable, the build that we did earlier. And for command line to run in the Docker container, let's type in ROS launch io_turtle and turtle.launch. This is the command that's going to be run in the container. Over here you see the resource limit. Just leave it as is. We can adjust that later. Now we're going to add some ROS topics. These are the topics that are going to be shared over the routed network. So for the topic name, we're going to publish share between the two containers. We're going to use sim/command velocity. Over here, we can see that QoS, or quality of service, is going to be high because the higher the QoS, the faster and more reliable the topic gets transferred over the network. Now we're going to add a ROS action. We're going to need turtle_0 go to action, and we also need turtle_1 go to action. So we'll just copy it there, and these are the actions that are going to be sent over the routed network. Click next and confirm the package creation. Go back to builds, and we can check on our routed network, and it shows that it's succeeded. Okay, so the next package we're going to create is going to be the UI package. This package enables people from outside to view the UI through a browser. Let's call it UI_interface. Remember, it's bindable. And let's write an appropriate description for it. Interactive UI for Turtlesim. Next. Here we are going to create a component. Let's name this component User Interface. For component runtime, it should be cloud, and it's a ROS component. And for executables, I'm going to create an executable, and we're going to call it UI executable. You can use any other name for the executable as you wish. For the type of the executable, select Docker. Now in the box, we're going to enter the Docker image URL. We're going to enter our Docker Hub /io Turtlesim UI, as the image is hosted in Docker Hub. The next thing we're going to do now is we're going to expose a communication endpoint. So let's enter an endpoint name, user interface. Make sure it is exposed externally, and this way we can access it from the public web. For protocol, leave it as HTTPS/WSS, and for the target port, enter 8080. This is the same port as the one that's exposed on Docker. Now we can confirm our package creation, and we're going to create another package. Click on Catalog from the navigation bar and add new package. We're going to name the package Simulator. The version is going to be set as the default value, 1.0.0. Let's enter a description for this package. Next. Now we're going to create a component. Let's call this component Simulator. Component runtime should be left as cloud. This is a ROS component, so keep that checked. For executables, we're going to call it simulator_executable, and we're going to enter the build that we have created earlier. We're going to enter a command to run in a Docker container. This time it's going to be ROS launch io turtlesim_env and simulation.launch. Now let's add ROS topics. The first topic we are going to add is the simulation pose. Click on Add ROS Topics and enter /sim/pose in the name field. Make sure the QoS, or quality of service, is set as low. Next, we're going to add the simulation sensors topics. Enter /sim/sensors in the name field. This is also set. The QoS of this is also going to be set as low. Now let's add a ROS service. To do that, click Add ROS Service, and in the name box, enter /register_sim_turtle. Similarly, let's add another ROS service, /teleport_turtle. You can ignore the timeout and the other settings for now. Click on Next and confirm the package creation. You can now check on your packages that we created in the Catalog tab. Finally, we are going to create the Command Center package. Enter the package name as Command Center, and the package version is set to default 1.0.0. Let's enter a description for this package. This package is going to be sending the commands that communicate between the turtle and the UI. Click on Next. Now we're going to enter a component name, Command Center. For component runtime, select Cloud, and this is a ROS component. For the number of replicas, leave it as 1. As usual, we're going to write an executable for this. For the name of the executable, enter CC executable, standing for Command Center executable. For the executable type, select builds, and let's pick the build we created earlier. In the command to run inside the Docker container box, enter the following command: ROS launch io_turtle_command center and command center.launch. Now we need to expose a communication network endpoint for publicly accessing Command Center. To add an endpoint, click on the Add Endpoint, and in the endpoint name box, enter the appropriate name for the endpoint, WS_ROS bridge. These endpoint names are important because they are used by other packages when adding dependencies, but we will take a look at this later. For the target port, enter 9090. Now we're going to add some ROS topics. Click on Add ROS Topic and enter command velocity. For QoS, leave it as low. Now let's add a ROS service. To do that, click Add ROS Service. In the name box, enter /register_turtle. Now we're going to add some configuration parameters. These will configure the environmental variables that are defined in the ROS launch file. Click on Add Parameter and enter WS_ADDR, standing for WebSocket address, and for the default value, enter 0.0.0.0. Let's describe it as WebSocket address. Similarly, let's add the WS port environmental variable, standing for WebSocket port. For the default value, enter 9090, and let's describe it as the WebSocket port. Click Next and confirm the package creation. You can now check your packages in the Catalog tab, and let's look at the packages we have created. Command Center, Simulator, User Interface, and Turtle. Now let's start deployment. Click on Deploy a Package and enter an appropriate name for the deployment. Let's call the deployment Command Center Deployment. Now we can look at the parameters we have created earlier, WSPort and WSADDR. Let's leave them unchanged. We need to connect the routed network that we have created earlier, Turtlesim network, and let's create the deployment. We can look at our deployments in the Deployment tab in the side navigation, and you can see that it is in progress. Click on the deployment and you can see more detail about it. Let's go back to Catalog and create our second deployment. This time we're deploying the simulator. Click on Deploy Package and name the deployment Simulator Deployment. You can choose any other name you want. Similar to the last package, we need to connect it to the routed network. Click Create Deployment and click Confirm. Now going back to the deployment section, we can see that the previous deployment, the Command Center deployment, has succeeded. You can go and check on your routed networks in the Routed Network tab and see more details about the routed network. We can go back to the Deployments tab and see the progress of the simulator deployment, and it's still provisioning. Now we're going to actually deploy the Turtle robot. Click on Deploy Package and enter the name of the deployment. For this, we're going to enter Turtle Deployment. Like all ROS components, we need to connect it to a routed network. Click on Add and select the routed network that we have created. Click Create Deployment and confirm. We can check on our deployments back in the Deployment tab and check the statuses and click on the individual deployments to see more detail on it. Next, we're going to deploy the UI. Go to Catalog and find that UI package that we have created earlier. Click Deploy Package, and we're going to call this deployment User Interface Deployment. Next, we're going to add some dependent deployments. In the dependent deployments section, click on Add Dependency. This is important because the UI depends on some of the external exposed parameters from the command center. Now we need to add the routed network. Click on Add and select the routed network that we've created. Click Create Deployment. And then we'll just wait for them to finish deploying. Now that we have finished deploying our 4 packages, we can just wait for the last one to finish deploying. You can click on it to look at the status of it while it's deploying. Now it's succeeded. To get a better understanding of what's happening in the deployments and how they relate to each other, we're going to head over to the Reputo.io walkthrough page and take a look at the software architecture section. Over here you can see the clear relationship between the nodes. The command center depends on the user interface, the simulator depends on that, and the turtles depend on the other two. The directions of arrows indicate the directions of the parameters. If you go to the packages section now, you can see the different topics and services and detailed information of each of them. We're going to go back to our deployment, and we can see the last deployment, the UI deployment, is finished. And it's now running. If you go down now, you can see a nice detailed graph of the different nodes and different topics, services, and actions flowing in between each container. You can see that all these topics get controlled by a common routed network, which we named Turtlesim network. Clicking on it takes us to the routed network page. The next thing we're going to do is take a look at our network endpoints and try to access the UI from the web. In the network endpoint section of the deployment, copy the URL for the user interface and open the URL in your browser. From there, we can see the Turtlesim viewer. The Turtlesim viewer offers some web services that are called to change the colors of different objects in the simulation. If you change the background color, it will change the image of the background color. Let's now make this turtle move. Set the linear speed to 2 and angular direction to 180 degrees. And click go for 1 second. You can see that it's starting to move in the circular trajectory. This takes us to the end of our tutorial for Turtlesim. I hope you enjoyed our video.